In the last lesson, we had a little session about how data is structured, and I promised to make a video to cover those people who had been absent because of sickness. So here we go. So this won't last long, but it will help you understand what we talked about in our session. So we have in our data structure options, we have a follow-on from the videos that I did before about data types and variables, but it's worth just going through a little bit of a refresher in terms of what we're talking about. So we talk about simple types, and there are three simple types: numeric types, char, and Boolean. Now they're the known simple types that we have. There are only three, easy to remember, but they're subdivided by their usage, and we talk about numeric types in two classes. We have integers, which are whole numbers, and we decide what the size must be to hold all the possible values that we need, but we must, as architects, save as much storage space as we can. It's not just storage space, of course, it's also processing space, because these will exist in RAM, and when we are storing numbers in RAM, there is, even though RAM is very, very good these days, very fast, very efficient, and very cheap, I suppose, there is still a cost in processing space when you have too much space used when you don't need to. So that's our job. We must save the space where we must. Now we talk about integers in size. We have big integers, small integers. Bytes are the smallest one of them all, which can hold values of up to 255. And then we talk about unsigned and signed. For floats, those are ones for numbers which have a decimal place after their main component. After there's 100.5 and so forth. So once again, we've got the same job to do. We've got to specify positive and negative types, and I've been through all this before, so I'm not going to dwell on it. And it's our job to make sure that you can hold all the values but save as much storage as you can. One of the hardest jobs in design of them all. So we talk about non-simple types as being alphanumeric is one of the non-simple types. And the alphanumeric can hold all the possible numbers, characters, and symbols that are defined in the architecture of your system. They are loaded into your system at boot time through the BIOS, and they are defined for the architecture of the processor that you're going to use. We store a character, and a character can have a number, a character, or a symbol. And we've got all of those defined in this structure of the set that we are using. Originally, it was the ASCII set, ASCII, which could hold a limited number of characters, up to 255 again. But now we use a system called Unicode, which allows people to store accented characters and so forth from foreign languages other than English. It started off just being English, of course. All computing was done in America and in Britain at the very beginning. And so we had to extend that once other languages start to be used commonly in computing. We store multiple characters as a string, and that's an ordered structure. It matters which order the characters are in, because the meaning will change depending on the order in which the characters are included. For Boolean, we just hold true and false, and they're stored in the system as 1 or 0. And although that's only a bit, a 1 and 0, a single item of data, 1 and 0, on, off, plus 12 volts, minus 12 volts, or so, all that sort of thing, we have to have a byte, because the operating system can't manage a bit as a unit of structure. We have to store things as bytes. So we're wasting space there, but how often are you using a Boolean? So here's our first data structure. Now, our individual items of data are stored in structures, and the array is the first one. So here's a definition of array in steps. It's a defined area in memory. We specify where we're going to keep it, and we give it an identifier, a name that we're going to recognize, rather than using the memory address where it's stored. An array is used to hold a defined number of values of a similar type. So we can declare an array of a certain type. And the values are called elements, and they're referenced using an index which is 0 based. So we've been through all that before. So I'm going to give you now an example. So let's look at the use of an array, how it's actually used in C# using Visual Studio. And it's very straightforward, I think, in most cases. So what we're going to do is we're going to have an array that's going to record perhaps student scores in a test. So how do we declare this? We use the word int to declare the type that we're going to store. We indicate that it's going to be an array by using an empty square bracket. We then name our array my scores, and then we instantiate it. We initiate it using new int 5. Now the 5 is saying I'm going to need a space in memory for 5 integer values. Terminate it with a semicolon, and that's the declaration of our array. Now how do we assign values to it? The values can be assigned in the scope of the program itself. As the program processes data, you can assign values into it, remembering that these are zero based, but you can also assign values at the time of declaration. So once again, the initial part is just exactly the same, but you'll see the curly braces at the end where I've assigned 5 data values into my array called my scores. So how can I use this? I would have a variable called score, and I'm going to take one of the values in the array and assign it to my new variable called score. So score, which should actually have a small letter there because to reflect here, is going to get the value which is stored in my scores 2, which is, as you remember, because it's zero based, the third number in the array, which is 17. So my variable score is going to get the third value 17 assigned to it. And that's how we use the array, and we work with that a lot in programming because they're very useful for iteration, as you can imagine. Starting at 0, we can iterate through all the values just by plussing up on the values. Really useful indeed. Let's now move on to structs. This is the second of the data structure types I wanted to discuss. And structs are very much like arrays in that they can hold multiple values, but this time the values can be of different types. We're not constrained by having to put ints in the array or strings in the array or anything else. They can be values of different types. So the members are named for assignment. So each data member that we're going to store is given a name so that we can assign a value to that part of the struct, to that component, that element, that member of the struct. And they're referenced using what's called dot notation. So the best way to look at that is with an example. I want to have a book, and the book has various things about it that I want to store. A title, an author, an ISBN, which is the international standard for referencing books, like a unique index, and then a date of publication, which is its date time. They're all constrained within curly braces, as you can see, and that's how you define a struct. So here I'm going to make a struct that I want to use in the actual program, and I'm going to say that it must be of type book, and I'm calling it my book. It's going to be a struct of book, and I'm going to be using my book. Now you'd assign values to all of the members of the struct, but this time I'm just going to use the title, and I'm going to say my book.title, that's the dot notation, is going to be introduction data types, semicolon. So that's how you use a struct. Let's now move on to classes. Classes are the third data structure that I wanted to discuss, and they're the focus of our attention in the unit that we're working with. So here we go. So classes are incredibly useful and are the common design process that are used in most programming these days. So they're like a struct and have different types of data members. They have a name, of course, they have a different type of data members, but this time they can also have method members. These are the things you can do with the data that the class is storing when it's turned into an object with data actually stored inside it. So we model our classes using a thing called Universal Modeling Language, UML, and our modeling language is pictures. They're diagrams. They're an international standard that can be recognized across languages, across cultures, and are therefore very useful for people who work in multiple locations around the world. So we draw a picture of a class like this. In the top box, in box 1, we have the name of the class. In the second part, in box 2, we have the title and define its type, the author, the ISBN, the date of publication, and so forth. And then this is the difference. In the third box, in box 3, we're going to put the method members. And this one has 2 method members, get details and years in publication. So you can see that that's the whole definition of the class. And our job is to look at a scenario and describe those things that we can work with as a single entity. Now in this case it's a physical thing. A book is something you can lift, you can touch, you can do lots of things with physically. But sometimes our entities will also be what's called logical. We can't actually see them in the physical space, but they exist and are sure for real, like a grade for a student. So it's our job to look at the scenario and identify the candidate classes that we will turn into classes in the program. A class should deal with just one thing. The book, although it has a date of publication, has nothing to do with the publisher who published it. A publisher will have a separate class, and we will deal with that as a different model. So our entities must deal with just one thing. And we've wrapped up this entity inside a single class because that's what we do with a book, nothing else. So let's define a class. We're going to use Visual Studio Community Edition in our work in the classroom, and we're going to be using C#. Absolutely, you can define classes in lots of languages, in Java, which is another C-based language, but also in VB.NET. Inside Community Edition, there are some useful shortcuts for definition of the classes, as you've seen in the videos before. And I've also want to make a big focus on comments and coding conventions, because this is where some of the higher grades for your unit scoring in the assignment are going to be achieved. We talk about having well-formed code, and our well-formed code is going to improve the readability of the code, because we're going to make you to use a structure, a forming convention, which allows naming structures to have semantic value. When somebody sees that something starts with a lowercase letter, like in Camel Case, or a capital letter with Pascal Case, they can determine things about that item just by the way it is named. We talk about control naming using certain formats. Now, I use a format which is described in one way, where other people use different formats. But the important thing about all of this well-formed code is about consistency over any particular style. If you're consistent, and probably a team who are developing code will agree on a style that's going to be used, but that'll be used consistently so that all the members of the team can look at the code and identify what each item in the code structure is about, what it's for, what its purpose is. And that improves the maintainability. It means that if there are bugs, people can look at it and recognize the items for what they are. It will also help you as the developer, because in 6 months' time, you'll have forgotten how you solved a problem. I promise you, you'll have forgotten. And if you've put good commenting, not too much, just enough to prompt the thoughts, then those comments will help you maintain the application later when somebody either wants it extended or they want to change the way in which something is done. That makes it really easy to share all of the code across different teams, remembering that most applications will be developed by a team of developers, each with a different skill. So the whole thing that's done is from lots of different code components that are joined together to make the application. So let's look at a code structure in C# for our book class. So I've modeled it as public class book. Now we're going to talk about scope. Please don't worry about that just at the moment. And we've got different types of data members. We're talking about the 3 public data members, title, author, and ISBN. And you'll notice that I've used Pascal casing to name those: capital T, capital O, capital A, capital I. These are public. Now these are the getters and setters for the class that allow us to retrieve data and to store data, get and set. Then we've got an encapsulated data member, the private date time date of publication, and the green squiggly says it's complaining that I never use it. We're starting to use Camel Case for this type of data member. However, it has a public interface which is going to be declared using the Pascal case, capital D. So we've got the data set, the setters here, the getters and setters, and you'll see how they work. It's going to return the private member, and then they assign a value into the private member. So let's now look at the method members. These are in box 3. Remember, they were described in the UML in box 3. So we've got 2 method members. One is called getDetails, and this one is going to return a string, public string getDetails. And the way in which the return is achieved is by getting the title of the book, adding the word by with spaces, and then the author of the book. It could be anything. That's just what I've decided it should be. And then I've got the framework for calculation of the public year of publication. And what we would use is we'd take the date of publication, and we'd manipulate it against the current system date time, extract the years, and do a subtraction of years against the two values, and we would get an integer value for the number of years in publication. So public int years in publication would be as easy as that. And that's how we work with the classes inside C#. Very straightforward, and you'll get very used to it as we go through what we're going to do in the course.